NASA has long dreamed of returning to the moon, but today that dream is fueled by fierce competition. Elon Musk's SpaceX is no longer just launching satellites. It's actively aiming to dominate lunar transport and infrastructure. This new space race isn't just about exploration. It's increasingly about resources, influence, and even geopolitical leverage in space. NASA's Artemis program plans to land the first woman and the next man on the moon by mid-decade. Meanwhile, SpaceX's Starship, with its enormous payload capacity, was chosen by NASA to deliver astronauts to the surface. For the first time in history, private companies hold the keys to unlocking humanity's permanent return to the moon. The original moon landing in 1969 was about Cold War supremacy. This one's about ownership and sustainability. As SpaceX pushes boundaries, Blue Origin and other private players aren't sitting idly. They're also eyeing lunar contracts. Mining lunar ice is one of the biggest prizes, potentially unlocking endless drinking water and rocket fuel production. NASA scientists believe water ice trapped in shadowed craters could sustain entire future moon bases and space stations. Elon Musk has publicly stated that his goal is to establish a self-sustaining city on the moon and Mars. SpaceX's reusable rockets slash costs, making long-term lunar presence not only plausible, but increasingly cost-effective. The Artemis Accords, signed by more than 30 countries, aim to create peaceful rules for lunar exploration. However, countries like China and Russia have declined to join the accords, favoring their own lunar alliances. China's Chang'e missions have already returned moon samples and scouted locations for a potential research station. With multiple nations eyeing the same lunar regions, questions of sovereignty and territory become increasingly complex. No nation can officially own the moon, per the 1967 Outer Space Treaty, but usage isn't prohibited. Elon Musk interprets this grey legal space as an opportunity to build infrastructure where governments hesitate. NASA is publicly funded and subject to politics, while SpaceX operates with commercial speed and private ambition. This contrast fuels a dynamic race, caution and consensus versus innovation and disruption. Moon missions no longer launch once a decade. They're scheduled annually or even quarterly in the coming years. The moon's south pole is especially valuable, rich in water ice and bathed in near-constant sunlight. Solar panels on ridgelines and ice mining in craters could power entire lunar bases indefinitely. NASA plans a station called Gateway to orbit the moon and support surface operations long-term. SpaceX's Starship is expected to shuttle between Earth, Gateway and the moon's surface with incredible efficiency. Some experts warn that lunar land rushes could mirror harmful patterns of colonization seen throughout Earth's history. With billions at stake, the moon may become the next frontier for legal disputes and corporate rivalries. International lawyers are already preparing legal frameworks for lunar property rights and infrastructure ownership. Companies like Intuitive Machines and Astrobotic are developing robotic landers to lay the groundwork for human missions. These missions will scout terrain, test survival tech, and establish communication networks for future astronauts. SpaceX envisions a system where Starship builds habitats, deploys satellites, and even manufactures structures directly on the moon. 3D printing using lunar regolith could allow construction without hauling heavy materials from Earth. NASA's Lunar Terrain Vehicle, LTV, will act like a lunar jeep, exploring for minerals and potential shelter. Elon Musk sees the moon not just as a destination, but a critical stepping stone to Mars. Moon bases could act as refueling stations, emergency shelters, and tech hubs for deeper space missions. The moon's low gravity makes it an ideal launch site for missions farther into the solar system. As NASA lays the groundwork, SpaceX is racing to master reusability, speed, and logistics at scale. For Musk, the moon is also a cultural milestone, a proof of concept for interplanetary living. The public is increasingly fascinated by lunar missions, with launches streamed live and watched by millions. Social media helps humanize astronauts, engineers, and even the robots heading to our celestial neighbor. Tourism might not be far off. SpaceX already sold tickets for a private lunar flyby mission. Japanese billionaire Yusaku Maezawa plans to take artists on a lunar trip to inspire earthbound creativity. Commercializing the moon could eventually include hotels, labs, and even studios for filming in low gravity. NASA's SLS rocket rivals SpaceX's Starship in scale, but lags in cost and flight frequency. Budget constraints and political oversight slow NASA's momentum, while SpaceX iterates rapidly and self-funds test flights. Still, NASA's scientific rigor ensures missions are safe, thoroughly vetted, and internationally respected. Many believe the ideal future combines NASA's legacy with SpaceX's ambition in a hybrid public-private model. Lunar agriculture experiments are already underway, testing which crops could grow in harsh lunar conditions. Radiation, lack of atmosphere, and extreme temperatures make long-term survival on the moon a major challenge. Innovations in radiation shielding, underground shelters, and AI-managed life support systems are being developed right now. NASA's Orion capsule will carry astronauts to lunar orbit, with SpaceX handling the final descent. This cooperation shows that competition and partnership can coexist in today's commercial space era. China plans its lunar base by the 2030s, built with Russia's help and hosted on the South Pole. As multiple nations aim for the same lunar regions, collaboration will be crucial to avoid conflict. Even private firms must respect space law, environmental protocols, and international agreements on peaceful use. Lunar dust, sharp and clingy, is a serious hazard that could damage suits, habitats, and machinery. New materials and nanotech coatings are being tested to reduce dust accumulation and protect sensitive equipment. The moon's far side, hidden from Earth, is perfect for radio astronomy, free from terrestrial interference. NASA and its partners want to build telescopes there to peer deeper into the universe than ever before. With permanent habitats, the moon may host the first interplanetary science labs outside Earth. Medical research in lunar gravity could reveal secrets about human biology in space environments. As launches become routine, costs drop, and more private players enter the moon race. Startups are pitching ideas from moon delivery services to rover-sharing platforms and autonomous lunar excavators. SpaceX's Starlink could provide broadband connectivity for astronauts living and working on the moon. This would enable live-streamed moonwalks, real-time collaboration, and entertainment from 250,000 miles away. Educational outreach is growing, inspiring a new generation of scientists, coders, and engineers with lunar dreams. NASA uses virtual reality to train astronauts for lunar missions with unprecedented realism and detail. Elon Musk believes failing fast is key. Each Starship explosion teaches valuable lessons for the next launch. The sheer scale of the moon race is drawing comparisons to the Industrial Revolution and space-age gold rush. Lunar infrastructure could create a multi-trillion-dollar industry, impacting energy, science, and global economies. Despite excitement, ethical questions loom. Who benefits, who is excluded, and who decides the moon's future? Indigenous leaders, ethicists, and philosophers are joining the discussion on space justice and inclusive exploration. Elon Musk sees multiplanetary life as humanity's insurance policy against extinction-level disasters on Earth. The moon is a testing ground for our survival instincts, technological limits, and societal values. It will take collaboration, not conquest, to thrive sustainably in space for generations to come. NASA's culture of patience and precision complements SpaceX's speed, ambition, and radical innovation mindset. Robotic missions teach us the terrain, but humans bring adaptability, emotion, and judgment to the surface. Each new moon landing pushes the boundary of what's possible in space and on Earth. In classrooms around the world, students now draw moon bases instead of skyscrapers or cars. Engineers design suits to withstand razor-thin air and punishing sunlight for weeks at a time. Some propose banking lunar soil as a rare earth metal resource for future earthbound use. Others worry mining could damage lunar heritage or disrupt natural formations over billions of years. Lunar tourism could one day include dome cities, low-gravity sports arenas, and crater-top resorts. For now, the focus is on sustainability, science, and survival, not luxury or vacation destinations. NASA and SpaceX both agree. The moon is only the beginning, not the final destination. Artemis missions aim to prove we can build, live, and thrive away from Earth's cradle. SpaceX wants to make these missions as common as airline flights, launching weekly to orbit and beyond. The next 10 years will determine whether the moon becomes a place we visit or a place we stay. New technologies, treaties, and test flights are already shaping the lunar society of tomorrow. Children alive today may one day raise families in domes beneath the moon's distant glow. This isn't science fiction anymore, it's engineering, politics, and entrepreneurship all rocketing toward the moon together.